Explain event loop in JavaScript. The event loop is a fundamental concept in JavaScript that allows for non-blocking asynchronous behavior despite JavaScript being single-threaded. It's the mechanism that enables JavaScript to perform tasks such as handling events, making HTTP requests, and running code without freezing the browser or applications. Key concepts. Number one, single threaded. JavaScript runs on a single thread, meaning it can only do one thing at a time. However, through the event loop, JavaScript can handle multiple operations concurrently without blocking the execution of the program. Second, call stack. The call stack is where functions are executed in JavaScript. When a function is called, it pushes onto the stack. When it completes, it's pop up the stack. If the stack is busy, other tasks must wait until it's clear. 3. Web APIs or browser APIs. These are the asynchronous functions like set timeout page, DOM events, etc. provided by the browser or Node.js. When these functions are called, they are executed outside the JavaScript call stack, typically in the background by the browser or Node.js runtime. Fourth, callback queue. This is where callback function wait to be executed. If there are asynchronous operations, the callback associated with this operation is placed in this queue after the operation completes. 5. Event loop. Event loop constantly checks if the call stack is empty. If it is, it will take the first task from the callback queue and push it onto the call stack for execution. This process is repeated, ensuring the program remains responsive and non-blocking. Flow of the event loop. 1. Code execution. The JavaScript runtime begins executing code. This will includes this will include synchronous functions that run immediately and get added to the call stack. Second, asynchronous task. When an asynchronous function, example set timeout, a network request, or an event listener, is called, it's handed off to the browser's web API or Node.js API to handle it outside the main thread. 3. Callback queue. After the asynchronous task completes, its callback is moved to the callback queue. Fourth, event loop. The event loop continuously monitors the call stack. If the call stack is empty, that is, no code is currently being executed, it moves the first callback from the callback queue to the call stack for execution. 5. Repeat. This cycle continues, ensuring that the asynchronous code runs without blocking synchronous code. Example of event loop in action. Execution flow. 1. Start is printed immediately because it's a synchronous operation. Second, the set timeout function is called with a 0 millisecond delay. The browser or Node.js API handles this and places the callback into the callback queue. 3. End is printed next since it's also synchronous and happens right after the console.log start. Fourth, the call stack is now empty, so the event loop moves the callback from the callback queue to the call stack. When then which then prints this happens later. Even though the timeout is 0 millisecond, it does not execute immediately. This happens because the callback is only executed after the call stack is clear. Why does the event loop matter? Non-blocking input output. It allows JavaScript to perform non-blocking operations like file reading, HTTP requests, and event handling while keeping the main thread available for other tasks. Concurrency. It makes it possible for JavaScript to appear as if it is handle multiple tasks at once, even though it only has one thread. Micro task versus macro task. In JavaScript, tasks can be categorized into macro tasks and macro tasks. Macro tasks. These include things like set timeout, set interval, and input-output events. Micro tasks. These include things like promises, then cache, finally, mutation observer. Micro tasks have a higher priority than macro tasks. When the event loop checks the callback queue, it first processes all micro tasks before moving on to the next macro task. Example of micro task. Execution order. Start is locked. Second, end is locked. 3. The promise .then handler is a micro task, so it gets executed before any macro task like set timeout. Fourth, promise resolved is a good lock. 5. The set timeout callback is then executed. 6. Timeout is locked. This demonstrates that micro tasks are processed before macro tasks, even if the macro tasks were added first. Conclusion or summary. The event loop ensures that JavaScript can handle asynchronous tasks and events without blocking the main execution thread. It does this by executing the synchronous code first, then executing callbacks from asynchronous operation. When the call stack is empty, the distinction between macro tasks and micro tasks helps JavaScript maintain efficient task scheduling. Thanks for watching.